Good morning, welcome, and welcome back to everybody that joined us in the past 4 weeks. My name is Jawahar. I'm an innovation lead at Legrand's Data Power and Control Division. Today I'm joined by a new co-host, Jim Schur. I guess Joel just went to get a haircut, so we're gonna let him get his things taken care, and Jim's gonna do Joel's part today. So again, welcome and thank you for joining us. It's been quite a journey. It's been 4 weeks since we started this. We had no idea how long the lockout's going to last when we started it. So we scheduled it for 5 weeks to begin with. And this is week 5. And I think most of us are still working from home. So we're going to continue this in some form or the other. We may just go to a monthly cadence. So Jim will talk about it after the live demo portion. So again, to talk about today's topic and the speaker, I'm going to turn it over to Jim. Jim?
Well, thank you, Jawahar. And as Jawahar said, my name is Jim Schur. I'm the Technical Services Operations Manager for Legrand at the Reno facility. And our session today is going to be talking about smart load shedding. This used to be a key activated feature that we had on our PDUs, but it's now available on all the firmware versions. And walking us through today's session will be Bruce Auclair, our post-sales senior system engineer, who's part of the technical support team here in Reno. Following the walkthrough, as Jawahar said, we're opening this up to questions. We'd also like to hear any features or topics you'd like us to cover and you feel might get some benefit out of in the future. For pressing issues, though, please contact us at support@servertech.com, or you can reach us at the 800 number that's available on the website. So with that, I'm going to turn it over to Bruce. The ball's in his court, and we'll talk about load shedding. Go ahead, Bruce.
All righty, yeah. Welcome, everyone. Thank you, Jim. Today's topic, as Jim mentioned, is smart load shedding. And this session is going to provide an overview of the feature and how to acquire it if your PDUs don't currently support it. I'm going to discuss the potential advantages of load shedding with the switched Pro Series PDUs. To talk about the available triggers for initiating an automatic load shedding event. I'm going to go through some of the setup steps, and then I'll give you a demonstration of a load shedding event based upon a high alarm for temperature. So let's get started. Hopefully everybody can see my screen. I'm
not seeing your screen yet, unless I have a lag here. Okay, now I do.
Oh, okay. Okay, so I'm going to log into a PDU at the Technical Support Lab in Reno, Nevada. And I have logged in at administrator level, which is needed to do what we need to do. Okay. So smart load shedding, which is found on the configuration system page. Load shedding was Server Technology's first optional key activated feature. It was introduced in July 2007 in our third generation switch PDU product line. It was originally called Smart Load Shedding, but the first thing to note is that the feature is only available with switched PDUs, which you can identify on the web interface by looking in the upper left-handish area. This is a switch PDU. If you have a smart PDU, that the smart load shedding feature is not available. If you do have a switched PDU, but you don't find load shedding in the configuration system menu on the left, this is an indication that your PDU is not up to date with respect to the firmware. The feature was added or made standard last year in July 2019, so that it is no longer key activated. And this occurred with our version 8.0p, as in Papa firmware release. So if you don't find it in your interface, you can perform a firmware update to get the feature, and the easiest place to find the firmware version is to go back to the overview page, and it's the very first item. So the current firmware release is 8.0R. The feature was added with 8.0P. If you're running something older, simply updating the firmware will then result in the next time you log in, you will find load shedding as an option. Okay. So what is load shedding? Load shedding, well, the original concept was, it was born from the understanding that at some point in the data center facility, there are uninterruptible power systems, power supply, UPS systems, that are ultimately providing power to the PDUs and the equipment in the cabinet or rack. And we realized that since most of these UPS systems are network enabled, we can communicate with the UPS systems by SNMP to determine whether or not the UPS is receiving utility power or whether it is running on battery. That is, utility power has gone off and the UPS batteries are providing power down to the equipment downstream. So with this knowledge, we decided we could automate some power control features with the intent to be that when a UPS loses utility power, we can then switch off pre-selected outlets so as to increase the runtime for critical gear. So the idea is that you shed the load of non-critical gear so that the batteries in the UPS systems will last longer for critical gear. That was the original purpose for load shedding. We've vastly expanded the load shedding capabilities beyond just reacting to a UPS on battery condition. But let's start by looking at that original concept. So the first thing that you would look at for using the on battery load shedding would be the UPS in configuration. So configuration system UPS. This is where you define the UPS systems that exist upstream of the PDUs. The system, the PDU system, allows you to define up to 8 different UPS systems. Presently, there's no purpose to have more than 4. One master PDU can support being linked to up to 3 link PDUs, in which case you have 4 separate PDUs, up to 4 separate circuits. So today, there could be use for you to define up to 4 UPS systems. Now, what I have logged into is a PRO2 master PDU linked to a link PDU. So one master and one link PDU, 2 separate circuits, and they are both plugged into 2 separate UPSs. That is to have true redundancy and no single point of failure. I've already defined the two UPSs, but it was as simple as starting by a name of your choosing. I chose for my first UPS, Falcon 2000 volt amp, 120 volt UPS A. I put that in, I used the drop down over here and selected my brand of UPS, which is a Falcon brand, Falcon Engineering. If you do not find your brand of UPS in this list, please try the generic RFC 1628 option. Nearly all UPS systems support that RFC, even if they have their own support. So for example, Liebert, I know, supports both their own MIB and generic. If you don't find yours in the list, choose generic. So I went ahead and defined a UPS A. I repeated the process. Oh, I'm sorry, you have to put in the IP address of the UPS. That is so we know where to go to talk to it by SNMP. So I defined one UPS as the A UPS. I defined a second with a different IP address as the UPS B. And I clicked apply and they showed up in this list. There's one additional step for each of the UPSs, and that is to click the edit button to the far right. And everything you see here is nearly the default. The only thing you need to really look at on this page is the community string. The community string needs to match the community string in the UPS, the upstream UPS. Public tends to be the default get community string for most devices. If you have changed the community string on your upstream UPS, you need to change that value here in the PDU so that it matches. Beyond that, you need to then tell the system, in this case, again, this system is a master PDU identified as the A PDU and a link PDU identified as the B PDU. You need to tell the system which UPS is powering which PDU. My A UPS is powering my master PDU, so I previously clicked that box and clicked apply. And for the B PDU, I went in and told the B PDU, the link PDU, that the UPS B is powering this system. So UPS B powers the link unit, UPS A powers the master unit, and that completes the configuration for UPS setup. This allows the PDU to go out and query the UPS every 10 seconds for whether or not it is on battery versus on utility. Okay, so we've gone back to the primary load shedding page. You do need to enable the UPS on battery load shedding. There, by default, all of the load shedding is disabled. So simply updating firmware to get this feature, there is no risk that you could end up having things switch off as a result of a load shedding event. I have enabled load shedding for the UPS on battery. We do have an option to have a delay. That is, when an event occurs, when a UPS loses utility power, you can specify a delay before pre-selected outlets, which we'll look at next, actually switch off. You then have an option as well for on utility auto recovery. And if enabled, what that means is when utility power is restored, the UPS, we will recognize within 10 seconds that the UPS is back on utility power, and we will automatically switch the outlets that had switched off. We will switch them back on. And again, you do have an option to specify a delay. Okay. So the final step for an on battery load shedding event is to go down to the link here and select the outlets that you wish be switched off when the UPS loses utility power. So these are, and the idea again is non-critical equipment. I have selected 2 outlets on my master PDU. This is 30 outlet PDU. So I've got A1 through A30. I've selected outlets 22 and 23 to switch off. If the Falcon UPS A were to lose utility power, those outlets would switch off. I've done the same thing for UPS or for the link PDU, which is powered by UPS B. I've selected 2 outlets, 22 and 23. So if one UPS loses utility power, only the outlets being powered by it will switch off. And if both were to lose power, all 4 outlets would switch off. I don't have a good way to demonstrate a load shedding event, as in I don't have a way to kill power to those UPSs in the office at this point in time. But there are other options. We have vastly expanded the feature set and the additional things that you can do with load shedding. I'm going to start with describing line load shedding. Line load shedding is line current, that is current as measured at the input to the PDU. You can set thresholds, and if a threshold is exceeded, we can switch pre-selected outlets off. The next item to look at is branch load shedding. And before I describe what that is, I should mention that we are logged into a PRO2 PDU. The PRO2 series PDUs measure everything there is to measure, and that includes measuring current through each of the circuit breakers in the PDU itself, and that is what branch load shedding is referring to. So you can set a threshold for current through each of the circuit breakers within the PDU. And if that current is exceeded, then we will switch off pre-selected outlets. Finally, we have sensor load shedding, which I have already enabled. Sensor load shedding refers to temperature and humidity sensors that are attached to the master PDU and the link PDU. The master PDU supports 2 combination temperature and relative humidity sensors, and the link unit supports an additional 2. We see quite a bit more than 2 in this case, because this system actually contains what we call an EMCU, or an environmental monitoring control unit. That's this device that is located between the master PDU and the link PDU. And that device adds the ability for an additional 2 temperature and humidity sensors. So we see that as the E1 and E2 for temperature, and we see E1 and E2 for humidity. It also adds 4 contact closure monitoring points that can be wired to normally open or normally closed contacts, and a transition from one to the other is the trigger for the load shedding event. Finally, The environmental monitor control unit supports a water sensor rope that positioned somewhere in the data center there might accumulate moisture. If it gets wet, we can trigger an event that will switch outlets off that you have pre-selected. So we're not going to go through all of them, but I am going to take a look at temperature sensor event for the first sensor on the master unit. So this is where you configure which outlets will be switched off or on. I've selected outlets 1, 2, and 3, and over to the right we have a choice for each. That is, when an event occurs, you can actually choose to have an outlet switch off, or if an outlet is off, you can have it switch on. The purpose for switching on would be, for example, if you have cabinet doors with built-in fans or fans in the top of the cabinet, you can have those plugged into the PDU and they don't need to run constantly. If temperature exceeds your chosen threshold, we can automatically switch the outlet on to turn on those additional fans rather than turning devices off. Jump back to the load shedding page. And if you joined me in previous sessions, we saw how to configure thresholds, and we previously saw how to verify that you are receiving notifications by SNMP, email, syslog, and we've put in a nice little shortcut so you can just jump directly to the threshold settings for the temperature. So on this page, these are the default settings right now. There is a hysteresis. What that means, at least as configured today, the high alarm threshold is what triggers a load shedding event. If temperature, in this case right this moment, if temperature exceeded 50 degrees Celsius, the load shedding event would occur, and the temperature would have to drop down to 49 degrees Celsius in order for the outlet to automatically switch back on. And that would only be if auto recovery was enabled. I previously enabled that feature. So let's take a look at actually making a load shedding event occur. I don't have a good way to reach out and heat up the sensor, so I'm gonna be a little bit tricky. I'm gonna start by going to the overview page and taking a look at what the current temperature is as measured by sensor number 1. Temperature is 24.2 degrees Celsius. Let's take a quick look at outlet status. Okay. Outlet number 1 and 2 are presently on. Outlet number 3 is presently off. Go back to configuration, load shedding, use the shortcut to get to the thresholds. Warning threshold always needs to be lower than an alarm threshold, so I have to change both, but it is the high alarm that is the trigger. So I'm setting it for 22 degrees, which is under 24. The moment I click apply, the sensor will go into a high alarm state, and we will see, we won't actually see it because I won't be quick enough, but we will see that the outlets have changed their states. Okay. Take a look at overview first. We can now see that temperature sensor A1, the first sensor on the master unit, is in a high alarm state. And if we take a look at the outlets, we can now see that outlet number 1 and 2 are off. They were previously on. Outlet number 3 is now on. It was previously off. And as we can see over here, it was due to an event. Okay. And simply to demonstrate the auto recovery, I'm going to change those thresholds back to what they were previously. And we're going to go back to the overview page, and we will now see an alarm no longer exists. We'll take a look at monitoring for the outlets. And we can now see that we are back to what they were before. Outlets number 1 and 2 are on, and outlet number 3 has gone back off. And let's take a look at one last thing, and that is previous sessions we talked about verifying that you can receive messages, alerts messaging about events, and the same is true with all of the load shedding events. You have the ability to receive notifications of these events by email, SNMP trap, and syslog messaging, as well as by viewing the log manually. So we can see at one point that temperature went high. We had a load shedding event that turned off outlet number 1. The same thing for outlet number 2. It switched off due to a high temperature load shedding event. And then outlet number 3, which had been off, switched on. We see the same in reverse up here. After the temperature went back below the threshold, the outlets switched back on. So that is load shedding. I wanted to introduce that to you. Many of you may be up to date with firmware and simply may have not noticed that that feature is there when it was not there previously. Either way, I invite you to take a look at the load shedding page. If you do have questions, reach out to the support department. We can provide assistance. And with that, I will pass this back to, I think, Jim.
Well, thank you, Bruce. Great job. A lot of information there and a great topic for us to discuss. I don't see any current questions on the chat section. Javi, if you can unmute everybody, and if anybody has any questions, we'd love to hear them.
Yeah, for some reason, I don't have the option anymore, so you may want to try to unmute attendees, Jim. But while you do that, in the meantime, I have a question for Bruce. Bruce, you worked with customers on this, what I would consider a fairly advanced feature. So obviously there's going to be a lot of planning involved before somebody implements it and rolls it out across the board. So can you share some instances as to why people use this feature? Like what's the use case behind it?
Right. Well, everybody able to hear me? Yeah.
Yeah.
Yeah, I mean, well, a good number of use cases actually are in a lab environment where you might be doing stress testing of your deployments that will go into a production environment. But yeah, other cases would be maybe not a large scale data center, but for small data closets where you might have individual cooling units for just that small room. If you had a cooling unit go out, you could, a lot of people would agree that they'd rather switch the devices off and have some downtime versus having them continue to heat up and go off as the result of permanent failure. That actually is one of the driving reasons we added the temperature as a load shedding option. We had an event ourselves many years ago, I think 2007 or so, where in one of our small closets with 2 or 3 racks, yeah, that's exactly what happened. The air conditioning unit went out. Nobody at that time had things set up so that IT would be notified, and sure enough, we came in on a Monday morning to find 2 of 6 servers in one of the racks were permanently damaged. So that's one use case. You know, the water sensor, I know that that has been used in environments on Navy ships, for example, that are out and about in the oceans. And interestingly, with regard to the city of Reno, one of their data centers for the court system, family court system, and some other portions of the system where the data center was in the lowest level of the basement of fire department number 1, which is in downtown Reno, which is the lowest area of Reno, which gets flooded every 8 to 10 years. Now they've since moved. They've moved that data center elsewhere. But yeah, they had a very good contingency plan that took advantage of load shedding with our water sensors, so that if there was an event or a flood and the basement started to fill up, first off, things would switch off, saving the equipment, and they would get notified of that event, and they would send firemen down. They kept the cabinets on casters. They would unbolt them, roll them into the freight elevators, and bring them up before the basement filled up with water. So, you know, it all depends whether or not you have a need to use these. And maybe you find that everything that's being powered in your equipment cabinet is critical and you don't want to shut anything off. But at the same time, it's a good safety measure, especially with things like temperature. If nobody's around to react to a condition, the PDU offers the ability to do that for you.
That's great. That's a great example of
Yeah.
a true lights out management, where even if you're not around, you could have things taken care. One of
And with
the other questions I had, like I don't see any questions yet from the audience, but you mentioned you could not only turn things off as part of load shedding, but also turn things on. Can you help us with, like, what would be a scenario when you would want to turn things on when the load is high,
sure,
in any of these conditions?
well, not when the load only, as far as the load monitoring, we only have the ability to shed the load, to switch things off on load, that is amperage through the circuit breakers or through the line. But for temperature and humidity, yeah, temperature would be the best example. We in fact added the option to be able to switch outlets on due to request by a large customer, for the very reason that they had fans in the cabinet doors that they didn't want to run constantly, but in the event of temperature exceeding a threshold or multiple thresholds, they were then able to automate switching one fan on and then another fan on to increase airflow to assist with cooling rather than switching the device off. And the way that you would achieve that, you can have more than one temperature sensor. Obviously, we have up to 6 in what I just showed you today. So you can have different thresholds with different sensors that can trigger events to switch things on at different levels of temperature. So at one temperature, you could have an outlet switch on, turn one of the fans in the door on, and if temperature continues to rise, that you could follow up and have a second outlet switch on to switch on additional fans or additional cooling units. The contact closures, by the way, have been used for monitoring commonly door sensors. So if you have contact closures on your cabinet doors and you are, we've actually had people use those as emergency power off switches. If their cabinet security is compromised and that door is opened without being on a schedule, then the equipment could all turn off, which could be a safety measure if you're looking at a security incident where somebody is attempting to compromise your devices.
That'll be the trigger. Okay.
At a physical level, yeah.
All right, Bruce, I've got an online question. It says, it seems like this could also be used as means for emergency shutdown in the event of fire or water. Could it be used that way?
Well, yes, yeah. In fact, yeah, with the water sensor, you could, yeah. In fact, that's what the city of Reno used to do before they relocated that data center. They used it to emergency power off everything in the rack the moment water reached a certain point. The same with the contact closures could do that, and with the contact closure, yeah, you just need a switch. That could be an emergency power off switch. That flipping that switch would then turn one device, all devices off, up to you. You choose ahead of time. And I've also had customers use smoke detectors. There's a number of smoke detectors that have a relay built in so that the relay transitions from normally closed to normally open or vice versa. And that can be connected to a contact closure sensor that's with the optional environmental monitor control unit, and a smoke detector detecting smoke indicating a potential fire could switch off the gear automatically.
All right, another question. Could this also be used as a rudimentary method for power cycling life testing? Looks like it could be triggered via temp.
Yes, yeah, definitely. Yeah, whatever purpose you have, if switching an outlet on and off achieves your goal, we can set that up for all of these different events. Humidity, temperature, the UPS event that we started with, and then the current through either the lines measured at the input or through each circuit breaker, and as well as the contact closures and water sensors. There's a number of different possibilities out there. Most of the people that I know that are making use of it, it is in a lab environment, other than the one large customer that specifically deploys cabinets with fans in their doors and uses this feature to switch those fans on in steps when temperature starts to rise. especially useful in a lights out facility where there might not be somebody nearby, and you have to roll somebody out in a truck. The PDU can attempt to save your equipment before it goes offline due to damage from an over temperature event.
Awesome.
And I should mention that for those of you that might not be using our Pro Series PDUs, which began to enter the marketplace in very early 2015, if you're using our older CDU Series PDUs, they supported load shedding as well. It was always a key activated feature, and still is a key activated feature, but if you do have the older cabinet distribution unit series, not the Pro Series, we can provide you an activation key to enable that feature, and that would be provided at no charge. With the Pro Series, simply keeping your firmware up to date, getting to 8.0p and later automatically enables the feature for you.
All right. Very good, Bruce. Javi, you have anything else?
I don't see anything. I was not playing with my phone. I was getting questions on the phone, so I was making sure I get the answers right. So yeah, I don't see anything else that you haven't covered, Jim. So we can wrap this up.
All right. Well, thank you, everyone. We are going to move these videos now to a monthly format instead of weekly. Not because we're running out of topics, but because we need to get Bruce involved in some other projects as well. So the next one will be in mid-June, and we will send out the evites for that as well. I hope you all can make it, but thank you for attending these 5 sessions we've done so far. And you know, if you have any questions that you didn't get answered during the webinar, please send them in to support@servertech.com, and we'll get them answered for you as quickly as we can. So thank you, everybody, and look forward to seeing you in June.
All right. Thanks, everybody.
Thank you.